You're doing well. In this video, I want to talk about an application of integration to figure out the area between two curves. So I have two curves written down, and I have a whole bunch of work written on my page, but I'm going to go through this slowly and show you how I got all this. So let me start the problem. So I have two functions in mind, x squared plus 3x plus 1, and 2x squared minus 2x plus 7. I know I get two parabolas. They both open up. And they do intersect. And I will show you where they intersect and how I figured out this intersection. So when I have two parabolas and they intersect, I'm going to have a top parabola and a bottom parabola. And again, I'll show you how I did all this in a minute. So one of the things when I give you a problem, I'm just going to state the problem. Just this alone. What I would like you to do is call the top function, or I don't mean the top function, I mean the first function f and the second function g, because that's going to help me out with typing things into Mathematica. And again, I'll talk about right now how I got all this. So let me run over to Mathematica really quick. So the first thing I want to do is clear my functions f and g and the variable x, because I don't know what we've done ahead of time. I'll type in my function f of x, my function g of x, and now I want to figure out the intersection points. Two functions intersect when their functional values are the same. And that's why I'm using the solve command here. So if I evaluate this, I wind up getting x equals 2 and x equals 3. So what I'd like to do is I would like to plot a function on a plotting domain that contains 2 and 3. Well, 1 and 4, that contains 2 and 3. That would be my natural choice. But when I evaluate this, I can't really see the stuff between 2 and 3. So 1 and 4 probably wasn't a good choice. I'm just going to pick the endpoints because I know I'm going to get everything I need and then nothing else extra. So I look at this and I see this little tiny sliver. But I have a blue and I always call it a mustard curve. I have a top curve and a bottom curve. So I know my little sliver, I'm going to exaggerate it on my paper when I draw it. That looks like this. And right off the bat, I know this is the top and this is the bottom. How do I know the top is the g of x curve and the bottom is the f of x curve? Well, let me show you how I did that. Here's my thinking on this. If I take a point between 2 and 3, let's say 2.5. If I plug it into f and plug it into g, whichever function yields the largest output, well, that's the top function. So, really quickly, I am going to type in f of 2.5. And then I want to compute g of 2.5. And now I want to look at their respective outputs. Their respective outputs are 14.75, that's the f curve, and 14.5, which is the g curve. So, it's a good thing I went and I tested this in Mathematica, because this right here, this is the top curve. F of x is the top curve here. So, f of x is the top curve and the bottom curve is g of x. So I'm always going to want top minus bottom, so I got to switch this. This is wrong. This happens all the time when we're doing problems. You make an assumption on what's the top and what's the bottom, but you need to actually verify that you have a top curve and a bottom curve. So why do I want top minus bottom? Because I want a bigger number minus a smaller number. So what I really want for this is f of x minus g of x. That's top minus bottom. So this is going to represent some height of a rectangle. Here's my little rectangle. I usually just draw it as a vertical line. So I have a height, and now I need to multiply it by a width. Well, my width is in the x direction. I am going to call the width dx. So this right here should match that. This should be an F. This should be a G. I am going to take the height function. I'm going to multiply it by the width. And this is going to get me a height of a rectangle. This integral is going to get it up for me. And I know my bounds are 2 and 3. The really nice thing is that in this type of problem, I'm not going to ask you to show me your integration technique. I already know that I'm going to ask you other questions that are just going to involve the integration techniques alone. So I want to break this up and not ask too many questions or too many parts of this problem. So you could do this any way you want. You can do this by hand, or my suggestion is use the power of Mathematica. So let me go to Mathematica really quickly once again. I'm looking at this and I have my functions f and g. And I know f is the top curve and g is the bottom curve. I want to integrate this. So the really nice thing is if I go and I go to the palette, there's a basic tab and an advanced tab. Going to the advanced tab, I see a definite integral. So let me click on that. Let me put it down here. I'm going to click on that and I get a nice template. I have a lower bound of 2 and an upper bound of 3. Sorry about that. I had a Zoom session running and it just timed out. But my top curve is f of x minus g of x. And make sure you put these in parentheses, because if you look at what I had here, these are in parentheses. This whole height is multiplied by dx. And my variable, well, it's a dx. If I evaluate this, this will give me the area between the f of x curve and the g of x curve. Evaluating gets me 1/6. So again, I'm not looking for your integration techniques here. I'm looking for, do you know how to set this up? Do you know how to do the pre-calculus stuff in order to set up a calculus problem? And then I'm going to use Mathematica here. Make sure you show me your work on this. In other words, you give me your Mathematica notebook. I get an area of 1/6. So this is the area on that little slice. I hope this video was helpful. And if you have any questions, send me an email. Have a good day. Bye.